Hi, everybody. Welcome to section 4.3. We're talking about the coefficient of determination today. Now, remember, we're in the chapter. Chapter 14 is talking about linear correlation. And it's talking about finding a regression equation to see if we can predict a y variable based on some x variable. So we're talking about linear equations, and we're just using one single independent variable, the x variable in this case. So let's go ahead, and the coefficient of determination is a measure. Now, it's called the coefficient of determination. It's denoted r squared, so we'll put that here as part of the definition. The coefficient of determination r squared is a measure of how well the regression predicts y. Let's erase that real quickly. Predicts, and we'll say the y value. Now, the coefficient of determinant r squared is always between 0 and 1. And so, for example, say we get an r squared value of 0.57. What that would tell us is that 57% of the variation in y is explained by x. And we'll be more specific about this. I don't like saying generically y and x, but since that's all we're talking about right now, that's what we're talking about. So notice right now, 57%, well, pretty good, a little over half, but notice that's why it goes between 0 and 1. So notice values of r squared near 0 are really not helpful at all in figuring out what y is. So values of r squared near 0 are of almost no use. In using x to predict y. And of course, the other way, values of r squared near 1 are very useful. In using x to predict y. If you remember my last video where we were talking about finding the regression equation, and we had one where it was an exact match. We were finding air conditioner rates. If somebody was working at our house for so many hours, how much the rate would be. Or we talked about if we rented a car and they charged per mile, how many miles we drove would exactly determine what the charge was. Well, in both of those cases, we had a formula exactly for these values. Well, in both cases, we would have had an r squared of 1 because 100%, for instance, with renting the car, 100% of the variation in how much the total charge was due completely to how many miles we drove. So kind of to bring it back to what we had done before. But let me give an example. Say that suppose x equals number of hours studying and y equals score on exam. So say we're doing something like this, and suppose we got r squared is 0.68. Well, the way we would word this is 68% of the variation in y exam score. Of the variation in exam score is explained by number of hours studying. I kind of like to also look at it the other way. So the rest of the 100% from 68 would be 32%. The other 32% is due to other factors. So the reader can quickly say, hey, with 68%, almost exactly 2/3 of the variation exam scores explained by hours studying, but there's still about 1/3 that is due to other reasons. And so that's how I like to word these. If you look in the book, it's going to talk a lot about the formula to calculate r squared. We are not using the formula to calculate r squared. We're going to be using either the computer with StatCrunch, or we're going to use the calculator, the TI-83 or the 84 calculator, to actually calculate the value of r squared. I will be showing StatCrunch today on this video. If you would like me to do a video showing on the TI-83 or 84, just let me know and I will post one of those as well. Okay, so that's essentially all we're doing in this first section, 14.3. So let's jump over to 14.4 real quickly and see what's going on there. Okay, so now 14.4 is referred to as linear correlation. And this is going to start very similar to the correlation, the coefficient of determination we saw in the last section, but we've got something called the linear correlation coefficient. Oops, correlation coefficient. And it's denoted as R. So the linear correlation coefficient R is a measure of how close the data points fall to a line. I would say a straight line, but all lines are straight, so that's redundant. And so I'll show you a picture of these in just a second, but notice it's R. Coefficient of determination was R squared. In fact, R is the square root of R squared. And it might be plus or minus. Remember, when we take a square root, it's plus or minus. So what happens here, we can actually calculate R from R squared. We don't know the sign though, but the sign is the same as the slope. Remember, with regression equations, the slope was b sub 1 of the regression line. We'll call it the regression equation. So if you have a negative slope, then you'll have a negative value of R. If you have a positive slope, you'll have a positive value of R. And let's talk about those signs real quickly. If R is negative, so if R is negative, when X increases, Y decreases. Well, let's put a semicolon there. That's a lot of dots. when X decreases, so I should put a S there, Y increases. And so notice if R is negative, X and Y go in opposite directions. Let's move that up so I quit hitting that with my fingers. Okay, I'm also going to make this Y look more like a Y and less like a G. Okay, so that's the first part. If R is positive, and I'm going to do this a little shorthand, when X increases, Y increases. When X decreases, Y decreases as well. It's not a very good line down. We'll change both of those lines. All right, so when X goes up, Y goes up. When X goes down, Y goes down. Notice X and Y go in the same direction. That's what we would call a positive correlation. Now, here's a quick example of positive and negative correlations. A positive correlation would be something like when you go put gas in your car, and we're talking about the number of gallons you put in and the total cost. If you put in more gallons of gas, it's going to cost you more money. If you put in fewer gallons of gas, it's going to cost fewer or less money. That would be a case where R is positive because X and Y are going in the same direction. Now, if you go to say buy a pizza, and a pizza is $12, and you're splitting the cost of the pizza among some friends. And so let's let X be the number of friends who are paying for the pizza. Well, as the number of people go up, say you had 3 people, well, 3 people at $12 is going to be $4 a person. But now let's increase it. Maybe you have 6 people. So X increased, but now the 12 divided by 6 is only $2 a person. So as the number of people went up, the cost per person went down. That would have been a negative correlation because when X got bigger, Y got smaller. Okay, the value of R, remember it can be negative. It can go to -1 all the way up to +1. And it could equal, again, if you get -1 or +1, it's the points are very close to a line. And in fact, if R is -1, the points are exactly on a line. And if you get +1, the points are exactly on a line. Remember, the sign just has to do with whether the line's going up or down. It has to do with the slope. So values near -1 or +1, all points are close to line. And by the line, we're talking about the regression line, the regression equation once we graph it. And in fact, let's call that the regression line. We'll put a period there. And then values near 0 points are very spread out. And we'll put in parentheses, nonlinear. And what I'm going to do, I just took a picture out of the book that I will post on here so that you can see some examples of these. All right, so let me move that out of the way and let me, oops, let's go right here. See if that'll paste right in. Ta-da! Okay, so here's some examples. Notice here's a line. All the points are exactly on the line. So the value of R is 1. Since the line's going up from left to right, the R value is +1. Had those points all on a line, but going down, the R value would be -1, and you can see that right below. Now, right next to that, we have a value where the R value is close to 1, it's 0.9, and we can see all the points are very close to the line. Again, the slope's going up, that's why the R value is positive, compared to straight below that where the R value is -9. Values are still very close to the line, but the line's going down, so it's negative instead of positive. So that's a strong positive or a strong negative linear correlation. And then we've got C and F where the R value is 0.4, either positive or negative. And so you can see that the points are pretty spread out. You can definitely see there's a pattern on C. It is definitely looking like it's going up. In other words, when X gets higher, Y is getting higher. And on F, as X gets bigger, Y gets smaller. Looks like the pattern's going down. So we do have a line, but it's a much smaller value of R. And then down at the bottom on G, there's no pattern that looks like it's necessarily going up or down. And this value of R is very close to 0. They're stating this value of R is exactly 0, which may be a bit overzealous, but that's the idea. So that's a nice visual of all the types of things that we can have. Okay, so what I'm going to do from there, I'm just going to jump into a problem. We're going to work some of these things. I'm going to show you on StatCrunch how we get both the values of R and the values of R squared from the last section. Okay, so remember, we're not going to have to calculate these by hand. So let me jump into StatCrunch. So I've already pulled up the problems here, but I have to move over to homework. Okay, so let's look at problem 23. I'm in chapter 14. Okay, so here's problem 23. Let's go ahead and go through this one to get an idea of what's going on. And notice they've already given me a graph, the scatter plot. Hopefully when you look at that, you say it looks kind of linear. The line's going down if I were to draw a line through there. So if I were to draw a line, let's see. Maybe the line would look something like this. Might be a little high, but something like that. So I'm expecting my value of R is going to be negative. Those points are pretty close to a line. So I do expect it to be close to +1. We'll see exactly what it is as we do this calculation. But let me show you how they graph that line in case you don't know. So here's what I'm going to do. Let's jump over. I'm going to clear that line off of there. And they've got all the data there. I'm going to click on the data. We're going to open it in StatCrunch. And so StatCrunch opens, it already put all the data there. Notice as opposed to my last problem that we had shown in the last lecture, it was just X and Y. Well, this time they're telling you, oh, it's age and price. They do put the X and Y there also, but they don't always. But what I want to do is I want to do that scatter plot. So I go to graph and I come down and I pick scatter plot. And it asks me, well, what's the X variable? So I say, oh, the X variable is age. What's the Y variable? Oh, the Y variable is price. The rest of this is optional to draw the graph. I just click on compute. And there's my scatter plot. So that's how they created their scatter plot. We've got our own scatter plot. We don't need their scatter plot. Okay, so let me go ahead and close this down because they already drew it for us. And I'm just going to drop that down. Maybe we can pull that right back up. Okay, let's see. Let me check something real quickly. All right, so we're back on our problem. Hopefully you got to see me graph that. If not, we will do another one. Okay, obtain the linear correlation coefficient. Remember, that's the value of R. Well, here's how we do R. So we're going to go. We've already got the data there. Let's just pull up the StatCrunch we just did. StatCrunch. And there it is. So what I'm going to do this time, I want to calculate that value of R. So I go into stat. This time I go down to regression, simple linear. This is just what we did before when we found the regression equation. Click there. Again, I tell it, oh, the x variable is age, the y variable is y. The y variable is y, that's very nice, which is price. And then I'm going to go and I'm going to compute. They ask me anything here that I need. I don't think so. Compute. And let's see what they give us. So I can come down here and notice right here, they give us the correlation coefficient R. And they say, oh, it's negative 0.903. We've got a bunch of stuff there. Let me write that down. So I'm going to write a couple things down here because it'll carry over for us. So my value of R, we usually do lowercase r instead of capital R. You can see they do capital. In fact, what's happening here is if they do capital R, it usually represents the population. So if this is the entire population, not just a sample, capital R would be the correct value. And they don't know, they're just making an assumption. So R equals negative 0.90328. 90328. So I'm just taking a few decimals. I know they're not going to ask that many, but I want to be able to round to the correct one. And the R squared value, which actually if we put that R value in there and squared it, we would get the R squared value, is 0.81592. 0.81592. Okay, so that was just these two numbers right here. So that's what I pulled. Okay, I'm going to erase that. Okay, so I've got those values. So let's go back to the problem and see if we can answer some stuff. So here's my problem. So they said, what's R? Notice I have R written up there still, so that's handy. So I'm going to enter that. Let me pull up my keyboard and round to 3 decimal places. So we say it's negative point to 3 decimal places, 903. And we'll check that. We get the right answer. And it says there is a what between the two variables? Well, let's see what they're asking. There is a, okay. So is it positive? Is it negative? Is it strong? Is it weak? Well, it's negative because it's a negative R value. And it's strong because it's close to -1. Remember, values of R that are close to -1 or +1 would be very strong. So we're going to say, oh, there's a strong positive linear correlation. Notice it always says linear. That's all we're checking for. There may be a correlation that's not linear that we could model with something else, but for our purposes, we're just looking to see if there's a linear correlation. And this one does have it. Ooh, I said positive. I would have got the wrong answer, wouldn't I? Because it's a strong negative linear correlation. All right, nice work. I appreciate that. Okay. The given graph is, I don't even know what they're asking here. Let's see. Consistent with the interpretation found in part B because the Y values appear to be blank as X increases. Well, what's happening? The Y values as X increases, notice it's a negative correlation, so they're going in opposite directions. As X increases, the Y values are coming down. So instead of this X, I had the Y way up here. Well, now when I have a bigger X, I have a smaller Y value. So the Y values appear to decrease as the X values increase, and the data points appear clustered closely about the regression line because they are. So we're saying it's consistent because the decrease was consistent with the picture that looks like it's going down. And it's a large value close to -1, clustered closely to the regression line. So we'll check that one. Good job there. And then they ask us again, hey, what's R squared? And they said, now find R squared. Well, we already found it. We had the calculator do it for us. So we will do this. It's 0.816. 0.816 And we'll check that answer. And we got that right. So now I do want you to be able to explain what R is, which they had us explain R in part C, but I also want you to be able to explain part D, what R squared is. So let's explain that. So I'm going to take that number. So we're taking this, R squared equals 0.816, and we're going to explain what it is. So remember, R squared tells us the percentage of the variation in the Y variable that's explained by X. So we can say 81.6% of the variation, let's see, and Y was the price, in price is explained by the age of the car. And again, if we want to word it like I did on that other one, the other, what's that going to be? 18.4%. Is due to other factors, explained by other factors. So we could look at something like this and say, hey, I realize that we get a lot of knowledge about how much the car is going to cost just based on its age. Well, there's going to be other factors, almost 20%, due to how well the car is kept, the options it has, a variety of other things. But a majority, 81.6% in this case, is due based strictly on the age. Okay, so that's the idea of this section. Not terribly deep or complicated. It's just those two ideas. What does R squared tell us? Well, it's the percent of variation explained by the regression equation. And what is R? Oh, it tells me how close the points are to a line. And it also tells me if the line's sloping up or down. Okay, so that's actually everything that I wanted to talk about in these two sections. We're done with chapter 14. Next time we'll jump into chapter 15. We'll do one section on that. It's actually hypothesis tests on this. And if we have time, we're going to touch on chapter 16, which will be our very last chapter that we do. If not, if we only do hypothesis tests next time, then we'll do all of 16 in the final lecture. So anyway, work with this. I'm sure you're going to be able to figure this out pretty readily. It's not terribly hard to do. And again, just make sure you get your work done. Stay on top of it because we're almost done. So keep up the good work and let's finish off the semester strong. All right. With that, I bid you adieu and we'll talk again soon.